Good morning, students. Today's session is based on the various types of data structures. Basically, the data structure is a linear and non-linear type. Now, for today, we discuss about non-linear data structure that is based on binary tree. In binary tree, we used array and linked list. So, the students, now what is a tree? In last previous session, you learned about linear data structure, stack and queue. Today, we discuss about non-linear data structure. In non-linear data structure, tree is a very important data structure. This data structure is based on the hierarchical relationships of various elements. In that structure, for example, if we create a record of our family tree, okay, or in a tabular form or in a hierarchical form. In your childhood, you may create a family tree just like your parents, first your father, then your mother, then your grandfather, your grandmother, and then so on. Okay, so the student, on the basis of that family tree, now we create a tree data structure. In a system, our data is also stored in a tree data structure. In this, for a various set of elements, just like we create the data structure, for example, in a tin, that is a one finite set. Okay, on that set, if we create their disjoint set just like a T1, T2, T3 and so on. So the T1, T2, T3 has various subtree, okay, and that subtrees are based on a various children's, just like a simple tree and leaves. Okay, students. So in that structure, one is the important part is a binary tree. By the name, you all are computer science student. You know that binary means in computer system it is 2. Okay. So in a binary tree, we divide our data sets in just like a basic one root node and their sub nodes, that's also called a child nodes. For example, students, see this diagram. On that diagram, there is a one root node that is 8. Okay, students. On that root node, we connect two child nodes, 3 and 10, according to that diagram. On that diagram, 3 is a left subtree and 10 is the right subtree. Why we call so? Because from the root, we see that 3 is the left part of the root node 8 and 10 is the right side part of the root node. So we create that tree based on root node 8 and their subchilds 3 and 10. After that, we follow the left side of tree. On that again we divided into two parts, 1 and 6, and again that divide 4, 7 and 13. That is a subchilds of the root node. Okay, just like a U for the your grandparents. Okay, grandparents, parents, and then childs. So the students, after this tree, what happened to C? On that tree, we divided every root in two parts. Sub child parts means sub left part and right part. So on that binary tree, what we see, trees follow the basically two or three things. First is whenever we create a binary tree, it is not an empty tree. Means there is a necessary condition of adding two child nodes. Okay, that is their childs. In a binary tree, first tree again we can say that the first is a root node, left side is a left subtree and right side is a right subtree. Why we called it is a subtree? Because in a binary tree, we always add two childs. Okay, this is a complete binary tree. Why we use binary tree, or what is the main basic application of binary tree? In a binary tree, we used for various software application because it's a non-linear data structure. So in software creating, if you want to searching or sorting the algorithms based on that, it is a very important tree. This shows student this is a full binary tree. Why we called it is a full or complete binary tree? Because every root node have a two child nodes. See and focus on that diagram. Every root node have a two child nodes. Okay, students. That is a called as a complete binary tree. Why it is a complete? Because if we see that tree, this tree, in every level we have a two child nodes and subchilds and so on. Okay, so that is a complete binary tree. Okay, students, thank you so much for the session. Thank you.